Hi developers, today we would be going to solve a problem called identical linked list. This is the problem from the Geek4Geek Problem of the Day platform. In this video, we would be covering the problem as well as understanding the approach. So without wasting much time, let's get started. The problem states that we are actually given two singly linked lists and our task is to check whether the given two linked lists are identical or not. So what is this identical? So two lists are said to be identical when they have the same data and the same arrangement too. So if this exists only, we need to return true, or else we need to return a false. So let's understand it with an example which is illustrated here. So we are given a two linked list, and in the program we are actually provided with the two head pointers, that is h1 and h2. So these are the two pointers that are provided to us. So our task is to check whether the two linked lists are identical or not. So what does this question states? So we are given two lists, okay? So we need to check each and every element of the given linked list and start comparing it. If they are not equal, we need to return false, and if they are equal, we need to return a true. So let's check it out. We will be first checking the first node. Are they equal? So 1 and 1 are actually equal. Okay, so we would be moving forward. So here we are moving. And again here we are comparing the two nodes. Are they equal? Yes, they do. Then we would be moving forward. Now we would be comparing these two nodes and checking whether they are identical or not. Since both the nodes are equal, we would be moving forward. And again we would be comparing whether the given two nodes are actually equal or not. Since 4 and 4 are equal, we would be moving forward. Now we will be comparing the node 5 of first linked list with the node 5 of second linked list. Since they are equal, we would be moving forward. Since we are done with traversing the linked list, we can say that both the given linked list are identical, and therefore we will be returning a true. So the output would be a true. Now let's look at another example and try to understand it. So this is the second example where we are actually given a two linked list, and this is the first pointer and this is the second pointer. As our process begins, we would be comparing the first node of the first linked list with the first node of the second linked list. Since they are not equal, we would be returning directly a false. And therefore, this is our output. That's what we are seeing. Now let's look at the approach. So the approach would be very simple and straightforward, where I will be using two pointers which are actually pointing to the head of the each nodes. Let's call it as P and let's call it as Q. And what I will be doing is, we would be comparing the P's data with Q's data. Okay. And if the data is actually equal, we will be moving the links one step forward. Okay. And if the data of P and Q are not equal, then immediately we would be returning a false. Let's have a dry run using this approach. So since we are given two head pointers of the two linked list, so we'll be creating two more extra pointers called P and Q, which would be initially pointing to the heads of each of the linked list. So P would be pointing to the first linked list head node, and Q would be pointing to the head of the second linked list. Now we would be start traversing the two linked lists simultaneously, and we will be comparing node whether the first linked list node's data is actually equal to the second node's data or not. This is how we would be traversing. So now let's start the dry run. So P and Q, is P's data, that is 1, and Q's data, that is 1. Are they equal? Yes, they are equal. So I would be moving the pointer P to one step ahead and pointer Q to one step ahead. So now I would be checking whether the linked list is empty or not, whether the pointer is actually pointing to the null pointer or not. Since they are not pointing to any null pointer, we would be again comparing the data. We will again comparing the elements. Now Is 2 and 2 are equal? Yes, they are equal. So we will be moving the pointer P and Q to one step ahead. Now again we are comparing both the elements. Since they are equal, we will be moving one step ahead. And now our pointer P and Q points to this two nodes. Okay, and our task again is to compare both the nodes element. Since the elements of both the nodes are equal, we again moving the pointers P and Q to one step ahead and start comparing it. Again we can find that both the elements of both nodes are equal. We would be moving the P and Q pointers to one step ahead. Since my pointers actually reach to the end, we would be returning a true. What happens if we don't have this? Which means we would be traversing till here, okay? And our Q pointer will be pointing to here actually. If that's the case, then what would be the answer? The answer would be very simple. It should return a false because there are 4 nodes in the first linked list and there are 5 nodes in the second linked list, which means they are not identical. For this case, the output would be a false. So after traversing both the linked list, we would be checking whether any one of the linked list is still there or not. Any one of the elements in a linked list still exist or not. If any elements from any one of the linked list still exist, that means our linked list are not identical. Now let's go to the platform and try to solve it. So this is the problem from the Geek4Geek platform, and here we are given a function called r_identical, which will be returning as a Boolean value, that is either true or false. So the first thing what we need to do, we need to create 2 pointers, that is P, which will be pointing to the head 1, the first linked list head, and there is another pointer called Q, which would be pointing to the second linked list node, right? And what our task? We need to traverse the whole linked list. We need to traverse both the linked list. So how do we traverse? So we'll check the condition can be done, okay? And during the traversal, what we are doing? We are performing an comparison operation, like we are comparing the 2 nodes, that is 2 nodes which are pointed by P and Q's data. Like, so I would be checking it. If P's data is not equals to Q's data, then we would be returning a false. So we will be returning a false. So this is P is actually pointing to 1 and Q is actually pointing to 9. Since they are not equal, our program would be returning a false. This is what this line of code does. If they are equal, if they are not equal, we are returning a false. That's fine. What happens if they are equal? So if you look at this example, the data of both the nodes are actually equal. We are moving a one step forward, right? So therefore, we would be moving a pointer to one step forward, P and Q to one step forward. This is how we are actually moving our pointers to one step forward. Once the traversing is done, we are returning a false, right? So what can be the condition? If you look at this example, when can we compare both the nodes? When we can do the comparison operators when actually both the nodes are present, right? So therefore the condition would be if P should not be equals to null as well as Q should not be pointing to null, then only we would be comparing it, right? As we remember in the examples, there is a case we discussed something like this where we are having unequal number of nodes in the given linked list. Like first linked list consists of 4 nodes, whereas the second linked list consists of 5 nodes. So in that case, what happens? Our program will traverse till here, and the first P would be pointing to a null, and the second pointer would be actually pointing to the 5. Even if the pointer is actually pointing to a number, then we can return a false, right? So therefore, let's add a condition check here. So if P, which means P is actually pointing to a number. If P is actually pointing to a number or Q is actually pointing to a number, then you need to return a false, right? And my bad here, it should be true, because at the end we are done with traversing the whole linked list. That means every node is actually identical, and therefore we need to return true. So this is what the program, and let's compile and run this program. As you can see, the program is giving the output as expected. So let's submit it. As you can see, our program has been accepted. That's all for this video, guys. Bye bye.